All right, let's take a look at number 32 from the chapter 15 bookwork. So here's my strategy. The first thing I'm going to do is I'm going to turn all of those grams into moles. And then I'm going to change all of the moles into molarity, because just remember that it's a 2-liter container. And the reason why you have to change it into molarity is because we're going to be looking for K sub C. And the sub C is concentration. Then I'm going to set up my ice table, initial, change, equilibrium, with the information that was provided. Alright, let's dive in. So I did a little bit of math, and I plugged in all the information that I know so far. So the big area that I want to concentrate on is to figure out what change would take the concentration from 0.340 of H2 to 0.140. So I'm going to do a quick math. I'm just going to subtract and figure out what that difference is. So I got a change of 0.200. Now remember, reactants are being consumed, so the amount should be negative, so negative 0.200. And there is a 1-to-1 mole ratio between hydrogen and bromine, so I can also assume that the bromine is going to drop by the same amount. Now, because there is a coefficient of 2 on the HBr, I'm going to double that amount, but make sure that it is positive. So it'll be positive 0.400. Alright, let's fill in those equilibrium values. The only part left on this first one is going to be 0.020, and this last one will be positive 0.400. And remember, that is molar. So that should give you the answer to part A. Those are your equilibrium concentrations. Now moving on to part B. They want you to calculate K sub C. So the K sub C expression looks like this. It's always products above reactants. And then whatever coefficient you have in the balanced reaction, make sure that that is your power. Alright, let's plug in our values and see what we get. It's a good thing I always check my work. Anyway, redid my math and double-checked everything. I got 57.1. Alright, and anyway, moving on to the next question. Okay, question number 42 is fairly similar. Step 1, I'm going to get the mass to moles. In step 2, I'm going to turn the moles into molarity, and then I'm going to take a look at that ice table, see what I can figure out. So the first part of this question wants you to figure out what the number of grams of I2 will be in that mixture at equilibrium. So thus far, this is all the information I've got. And you need to realize that what they did is they gave you the concentration at equilibrium of your I. And now they want the amount of I2 that's in the mixture at the same time, at equilibrium. Luckily, they gave you this. K sub C is equal to 3.1 times 10 to the negative 5. And remember, it's always products over reactants. So I would put I on the top, and I would put I2 on the bottom. And luckily, we have one of those. We have I. So I can go like this. 3.1 times 10 to the negative 5 is equal to 2.10 times 10 to the negative 5 over x. Now keep in mind they gave you K sub C, and sub C means that that is concentration or molarity. So remember, when you solve for x, you're going to get molarity. You need to go back and change that to moles, and then change the moles to grams. Let's do it. I got an answer of 1,720 grams. Alright, part B is a different problem and a different equation. But this time, they're working with K sub P. You need to be really careful here. Make sure that since you're using K sub P, that you are using pressure quantities. Ooh, gets a little tougher. Let's see. would personally recommend that instead of working around with K sub P, I would prefer to work around with maybe K sub C. I could, if I was working with K sub C, I could change the mass to moles and the moles to molarity, but just remembering that I've got a 2-liter container. So that would definitely be my first strategy. Then once I had K sub C, I could plug in these quantities once I change them to molarity, solve for the molarity of SO2, and then go back and change the molarity into grams. Alright, I hope this helps. Let's try this out. So the formula of changing K sub C to K sub P is the following, and delta N is always final minus initial. You know, delta, get used to delta being final minus initial. So on the product side, it looks like I've got 2 moles, and on the reactant side, it looks like I've got 3 moles total. So my delta N is -1. Alright, let's plug it in and see what we get. So I got a K sub C of 0.0172. Now that I've got my K sub C, I'm going to go ahead and change this information right here from mass to moles and moles to molarity so that I can go back and do my K sub C expression. I'll plug in those values using the K sub C, and then I will solve for the molarity of SO2 and change the molarity back into grams. Alright, this is what I've been solving for here, and my x squared is sitting on the bottom, and I can't remember the value of K sub C. They said, or we had calculated that, and that's 0.0172. 0.0172. Alright, now you just have to rearrange to solve for x squared. Okay guys, I got 176 grams. Now, I don't have my key with me, and I'm really hoping that this is correct. I can't really check my work until tomorrow when I see my key. Alright guys, I hope this is helpful. If you find anything wrong with my work, just let me know, okay? Anyway, I'll see you guys tomorrow. Happy trails.